Hello, welcome back to Haslam Maths. We've been off for a little while. We finished our GCSEs like 2 months ago and they went alright. Now we're going to do SURDS today. So the first thing we need to clarify while dealing with SURDS is what is a rational number. So a rational number is a number that can be represented as a fraction. So say a half, that's the same as 0.5 as a decimal. So rational numbers have a clear start and end, and they can be represented as a fraction. Recurring decimals are also an example of rational numbers. So for example, if I have 1/3, that's the same as 0.3 recurring. This is also a rational number. But now dealing with SURDS, SURDS is a way to represent irrational numbers. But what is an irrational number? So irrational numbers are what they sound like. They're random and they don't really follow a pattern. They go on never ending. So some examples of irrational numbers are numbers like pi. So you can work out pi using circumference equals diameter times pi. So pi is the ratio between circumference and diameter. So if you just run a lot of different numbers with the circumference and the diameter, you always get a more accurate version of pi. So it's always changing and it's always getting higher. Okay, so now I'm going to go through some of the rules of SURDS. So if you look at this equation, you have root 5 plus root 3 equals root 8. Now, if you've never dealt with SURDS before, you may think that's alright, because it's just 5 plus 3 equals 8, but you add the special sign. But with SURDS, you can't do this. So I like to think of it, it's like algebra, it's like collecting like terms. So if I have a is equal to root 3, and I do a plus a, that's going to equal 2a. So if I replace them, the a's, I get root 3 plus root 3 is going to equal 2 root 3. So the rule is that you cannot add or take away surds like you would with normal integers. Okay, on to our next rule, which is multiplying with surds. So we have root 3 times root 5. Now, with surds, you can multiply and divide them. So it's just the same as doing 3 times 5, 15, and then you keep the root sign. So I can also do the inverse of this to show division. So root 15 divided by root 5 equals root 3. Another important rule that is to do with multiplication or powers is that when you times a surd by the same surd, you get the number without the surd sign. So I'll explain this better. So root 3 is the same as writing 3 to the power of a half. So if I do 3 to the half times 3 to the half, if we follow indices laws, we know that it will be equal to 3 to the power of a half plus a half, which is 3 to the 1, which is 3. So if you square a root sign, you will get just the base number without the root sign. Okay. Now the final part is simplifying surds. Now this can start off quite easy and get more challenging, but you just need to get used to it. So if we follow the rule before of root 4 times root 4, we know that if you times a surd by itself, you get the base number without the surd. So you just get 4. But say we go back to the multiplication part, we also know that root 4 times root 4 is equal to root 16. Now, if you notice about root 16, that's a square number. So whenever in surds you see a square number, underneath the surd, you square it to get the whole number. So I'll do some examples. So root 25. That is the same as writing root 5 times root 5, which is the same as writing 5. So these are the basic ways to simplify SURDS, but you can get it in SURDS with more complex numbers. So say I use the 25 and take root 50. So you can see that root 50 isn't a square number. So we have to sort of split it up into a square number and whatever's left, if we can. So think about the factors of 50. I'm thinking 25 is a square number and 2 isn't a square number, but these times together will equal 50. So we say that root 50 is the same as writing root 25 times root 2. So we can simplify the root 25 to 5. So this is the same as writing 5 times root 2, which we just write as 5 root 2. Okay, now I'm going to just run through a couple more examples of simplifying SURDS so you get the hang of it. So I'll take root 48. So you want to find a square number that goes into root 48. So if I think of my 3 times tables, if I do 16 times 3, I'll get 48. 16 is a square number as we saw before, so root 48 is the same as writing root 16 times root 3. We know that root 16 simplifies into 4, so root 48 is the same as writing 4 root 3. Now if I do another example, I'll take root 200. So again, think of the square numbers, you know. 200, I think 100 is a pretty obvious factor. So you have 100 and 2. 100 is a square number. So if you can write root 200 as root 100 times root 2. Root 100 simplifies into 10, which gives you 10 root 2. Okay, thank you for watching the video. I hope you can understand SURDS a bit more. Possibly in a later video we'll do something like rationalizing the donut. Guys, thank you for watching the video. I hope you understand SURDS and I hope you watch more of our videos. Subscribe.